Hey guys, welcome back to my kitchen. We're going to do another lab here together. And this one I planned more as a demonstration, but if you happen to have these supplies at your house, you are welcome to try it out yourself. So the things that you would need is milk, water, orange juice, cornstarch, vinegar, baking soda, and iodine, which some of your families might have in a first aid kit. Now, you could just try out some of these combinations without the ingredients that you don't have. So it's totally up to you, or you can just watch me demonstrate it and make observations of your own. So please take out your science notebook, turn to a new page. We should be looking more at chemical changes and how can we identify those. So take out your science notebook and you're going to, on a new page, make a title, Making Changes, How Can You Identify a Chemical Change? So in our lesson yesterday, we read about all the different forms of chemical changes, how they form a precipitate, or how a gas is let off, or there's a color change. All these different indicators for how we know a chemical change has taken place. We're just going to model that and see it for ourselves again today. So here we go. Let me move this down. So I have my test tubes here, and I've got 3 test tubes with milk, 3 test tubes with water, 3 test tubes with a starch solution. So what this is this is a mixture of cornstarch and water. Now, here's something interesting about cornstarch. So, cornstarch isn't water soluble in cold water, so it's insoluble. So you would know that, like, if you've ever made slime, if you've ever made slime with cornstarch and water, like the oobleck, where you're able to play with it, or it's soft if you hit it slowly and it's hard if you hit it fast, cornstarch and water, that's because it's insoluble in cold water. So for this lab, I took cornstarch and water and I boiled it. And so that's what makes our starch solution here, is it's boiled and then you let it cool and then it stays in solution form. Okay, so think back to when we talked about a solute versus a solution versus a mixture. Remember, we did some doodle notes on that. Okay, so here is our starch solution. And then finally, let me move back down here, I've got my orange juice. So we're going to be testing each of these liquids against 3 different indicators. Okay, and so the indicators that we're going to be using here are iodine, vinegar, and baking soda. So those are our indicators. So in your science notebook, I want you to make some notes as we go about this. I want you to kind of make some notes, kind of jot down as you go, because that'll help you answer some questions for me here later. But basically, we are again trying to identify a chemical change. So to begin with, we're going to do, let me see how I can best let you see all of this. We're going to do baking soda first, okay? So I have my baking soda here, and we're going to do some baking soda into milk and just kind of see what it does and try not to make a humongous mess. Okay, so there's some baking soda into milk. Not seeing a whole lot. It kind of just clumped down into the milk from what I can tell. So there's our baking soda into milk. Now we're going to do our baking soda into water. So I grab my water test tube. So this is something you could probably do at home. Just throw some baking soda into water. What happens? Well, we're able to see a little bit more of the particles in the water. But still, does this indicate a chemical change? I don't think it meets our criteria. So I'm going to put that into my beaker. Now I've got my cornstarch solution. So we're going to add some baking soda into a starch solution. What do we have here? Oh, it just sunk down to the bottom. It let off a couple bubbles. I don't know if that's just from displacement as it's sinking to the bottom. You can kind of see the bubbles there. But otherwise, I'm not seeing anything phenomenal taking place. Just those few bubbles released. Okay. Now we're going to do baking soda into orange juice. Let me add this here. Okay, look at what's happening here. Does that... Oh, is it going to overflow on me? Possibly. Oh, it is. I need paper towels. Hey, I think something chemical happened, don't you? That would be a chemical change. We're definitely seeing that. I'm going to let it continue to overflow into my beaker here. It's going to keep going there. Okay, so that would be a fun one. If you've got some orange juice at home and some baking soda, that would be a fun little supper demonstration. Now let's move on to our vinegar. So we're going to follow the same order here, okay? So I'm going to do some drops of vinegar into my milk. Can we see? So it's very hard for you to see on the camera, but it's curdling the milk. It's causing the milk, can you see this? It's causing the milk to get chunky. So we could say that that's a precipitate. Like, that's a little disgusting. I don't want that anymore. Okay, vinegar into water. I'm not seeing anything. I'm not seeing anything. You just kind of head it on in. Vinegar into my starch solution. Again, I'm not seeing anything. Vinegar is acidic, so we would expect some acidic things to happen, but I'm not seeing anything with those. Vinegar into my orange juice. That's kind of like an acid and an acid. Not seeing anything there either. I would say this vinegar, now can you kind of see how it's like chunky? There's a little bit of a glare, but like that would be something happened, right? Something happened to make my milk all of a sudden curdle and get chunky. Okay, so that was our vinegar. So we're going to set that one to the side. And then last but not least, we're going to do our iodine. Okay, so iodine, let me show you here. It's like this rust color, but it leaves behind a yellow stain, which is why I'm wearing an apron. It's just to avoid the stain of it. It leaves behind this golden stain, and it's kind of almost like a grape juice color, I suppose. Whatever color you want to say that is. So that's our starting color, just for a reference point. It's kind of a red. Okay, so iodine into milk. See all your different colors leaking down? It's kind of just settling to the bottom, but you're able to see the color there pretty well. So that's kind of just settling down to the bottom from what I can tell right now. We can look at it again in a second, okay? Iodine into water. Oh, there you're able to see the color as it dilutes down, but nothing really happening. So iodine and water. Okay, iodine into our starch solution. Oh, look at that. It's getting blue. It kind of looks like a lava lamp because it's like grabbing onto the starches and then floating down. How cool is that? Well, I hope this isn't blurry. That is fascinating. So we've definitely had a chemical change because we had a total color change. Because look at the difference between, wow, that's really cool. Okay, and then finally, we've got our iodine into our orange juice. Oh, it's doing about this, it's about the same as the milk. It's kind of just settling down onto the bottom. So I would say our iodine and our cornstarch solution definitely is where the chemical change took place there. So that's your demonstration. And I'm going to flip over now to our lab sheet. So hopefully you took some notes in your science notebook. If not, maybe you need to rewind this video and make some. But basically here are our reflection questions. Okay, so we were looking at how we identify a chemical change. Your first question goes, which of these combinations and then the testing compound produced a chemical change? Okay, so again, our liquids were milk, water, cornstarch solution, and orange juice. Our testing compounds were baking soda, vinegar, and iodine. So tell me in your notebook, which of these combinations produced a chemical change? Second, how can you identify a chemical change? We read our lesson together yesterday. Okay, so hopefully you're able to reference that. So how can you identify a chemical change? 3, describe how you would design an experiment. So describe how you would design an experiment to find out whether an unknown white powder, what is this, is cornstarch or baking soda. So what experiment would you do to determine that? What results would you expect? And then how would you use the results to determine the identity of the white powder? So how would you figure that out? Okay, it's an unidentifiable, unknown white powder. Is it cornstarch? Is it baking soda? Based on the lab that we just did, what could I test it with to determine its identity? And 4, color change is an indicator of a chemical change. So, is adding lime-flavored drink mix to water and making the water green in color a chemical change? Explain your reasoning. All right, so those are your questions to answer in your science notebook for me. I hope you enjoyed seeing this lab, and if you've got some of these ingredients at home, go ahead and have some fun. Explore some science in the kitchen, and I will be here if you have any questions for me.